Let's get started. Welcome again, everyone, to join our Chicago Booth Alumni Speaker Series. My name is Cindy Zhao. I'm the Alumni Club President for the Alumni Club of China in Shanghai. We've been hosting this series for a few times. Obviously, tonight is the most popular event because we have 214 people registered for this event. We're gonna have a fantastic speaker. Also tonight, we are welcoming about 50 to 60 non-Chicago or Chicago Booth alumni to join us. Welcome everyone. We hope you are safe and healthy wherever you are. Obviously, we have a very international audience. Let me just give everyone a quick introduction of today's speaker, Dr. Dennis Ong. Dr. Dennis Ong is the head of CV2X at Verizon. Let's hear the explanation what CV2X means from Dennis. Previously, Dennis served as the chief architect and director at Nokia, where he led the system engineering team for the IoT Impact platform, which received the Best IoT Innovation for Mobile Networks Award at Mobile World Congress. And then at Alcatel-Lucent, he and his solution architecture team collaborated with 3 startups based in India, Israel, and Silicon Valley in creating a highly scalable analytics and video optimization platform that served 50 million mobile subscribers worldwide. Dr. Ong was a TEDx speaker at different events on topics including machine learning, 5G, smart city, autonomous vehicle, IoT, and blockchain. Dr. Ong is also a Booth alumni. If I remember correctly, it's from year 2010. And also a PhD in electrical engineering from the Ohio State University. He's also an adjunct faculty at the Ohio State University. Thank you, Dennis, for joining us from Ohio. And I know you have prepared a wonderful presentation. I think now you can start the presentation, and after your presentation, we'll have 15 to 30 minutes of Q&A and discussion. And if anyone has questions during Dennis' speech, feel free to post it in the chat room. We will answer your question after Dennis finishes his speech. Please go ahead, Dennis.
Thank you, Cindy. Thank you for the Booth Alumni Office in Shanghai and China for this opportunity to share with all of you. And I would like to say hello to everyone. Good evening to everyone in China. And maybe so there are some folks from the US, from Europe, or from India. I just say good morning or good afternoon to all of you. And as Cindy mentioned, I'm Booth alumni, and I've been using what I've learned in Booth in my career. And it's always nice to pay forward and to be able to share with you some of the things that I've learned through the years. In the last few years, I've been focusing my effort in 5G and also in autonomous vehicles. I'm heading the called CV2X, which is cellular vehicle to everything, which is using 4G and 5G to help autonomous vehicles and connected vehicles, basically to be safer and faster. Today, my talk will focus on 5G, the 4th industrial revolution. And I think all of us, especially folks in China, have experienced a lot of momentum in this area. I think for the rest of the world, especially in the US, Verizon and also other companies have been investing billions and billions of dollars in this technology. And so today I would like to share with you some of the exciting insights about this technology, how this technology is going to hopefully move our society forward in positive directions. So as Cindy mentioned, I'm going to present. And so there are also a couple of videos, short videos in the presentation. Hopefully it will give some insight to all of us. And at the end of the presentation, we'll have Q&A because we have quite many participants. And so I think having open discussion probably is difficult in Zoom. So if you have any questions, please go ahead and put it in chat. And Cindy will be a moderator. I think she will look at the chat. And then at the end of the presentation, we'll have a dialogue about the questions. Okay, so I'm going to share my screen now. Let's see. So I hope all of you can see the screen. So
the turning points in human history have all been about things. The Industrial Revolution was about machines. The space age was about science and rockets. The information age was about computers and data. But now, we are entering the age of humans. Truly, magnificently, utterly powered by people. Where people would be able to do anything they dream of. Children learning of atoms by seeing inside atoms. Doctors performing surgeries from miles away. The ability to see the invisible. To play, to learn, to live, to work, the way one only dreamt of. Because with 5G ultra-wideband, technology is no longer about what technology can do, but about what people can do with it.
So I really like the short clip that Verizon has put together for 5G, because when you look at 5G, it's really not just about, I would say, machines or smartphones, but 5G is about helping us as humans to be more productive as a society, and so it's going to impact not only how we communicate with each other, but how our entire society is going to communicate with each other. So for the agenda, first of all, we're going to talk about what is the definition of the fourth industrial revolution. What does that actually mean? The second is what's the outlook of 5G? What does it look like in about 5 years? As many countries are moving forward with 5G, how does that look like in terms of how many subscribers? How much bandwidth we're using in 5G? So there's some projection. I think this projection is very interesting. And what are the main ingredients of 5G? I use the term currencies. For example, like, is it faster? Is it, I would say, lower latency? What are the main, I would say, ingredients or advantages of 5G? And I'm going to go into a little bit about building blocks. In addition to about the advantages of 5G, what are the underlying fundamentals that make 5G superior than 4G? And there are a couple of interesting technologies that some of you may have heard about. One of them is called edge computing. How does edge computing work with 5G to make, I would say, this industrial revolution much more powerful? And I think some of you may have heard about health concerns of 5G, especially with pandemic. I think we have seen also some damages to cell towers. So are there really health concerns of 5G? And how about security measures? As 5G are going to be more prevalent and more important in our society, how can we make sure that 5G is secure? Use cases. I'm going to spend actually quite a lot of time on use cases. 5G is not just 1G over 4G. 5G is quite different. The use cases of 5G, use cases means that the applications of 5G will be much wider than 4G. And the last is the future. What's our future look like with 5G? So this agenda looks actually fairly overwhelming, and we could spend hours on this. I'm just focusing on the high level. I want to make sure that all of us have some sense about how 5G is going to impact us and impact how we relate to others and how we relate to society. The first is, what does that mean? 5G, the fourth industrial revolution. So when we talk about the fourth, that means that there are 3 previous ones before this industrial revolution. So it's good to look at what industrial revolutions have impacted our society. So the first industrial revolution happens 200, 300 years ago with water and steam power. So what that does is to give us more physical power. But it's actually very limited because we have to be very close to where the source of power is. But the first industrial revolution gives us a lot more physical power than what you used to be. The second industrial revolution, and some people call it electrical revolution, is that with electricity, we can distribute the power to places much further away. We could have conveyor belts, we could have factories that can do a lot of manufacturing for us. The third industrial revolution, somebody call it electronics or information revolution. This is where we have the silicons, we have computer chips, we have 3G or 4G, that we can basically be able to connect to some extent. We're able to have not only physical power, but mental power. We can increase our mental power with computers. And with connectivity, we can harvest that kind of mental power. The fourth industrial revolution is different than the third one. When you look at this, 4G and 5G are quite different because once we go into 5G, we are going to enable high connectivity and real-time enterprise. What does that actually mean? What does that mean by connectivity? If you look around, you may say that, well, everyone in the world almost has cell phone. Do we have high connectivity now? The answer is no. So if you look around, you may have 1 cell phone, 2 cell phones, you may have a computer, you may have an iPad. But if you look around in your house, for example, you may have 5, 10 devices which are connected to the internet. When we say high connectivity, we are talking about everything in your home is connected. Your doorbell, your TV, for example, your stove, your refrigerator, your water meter. You may have in-house camera system. Everything will be connected. So in a typical house, in 4G, you may have 5, 10 devices. For 5G, you could have 50, 100, 150 devices, which are connected all through your house. You may have devices connected to your ceiling, to your roof, because they can send information to the factory. For example, like in factories, you could have robots in the factory that could have hundreds of connections. In the future, that could be thousands, tens of thousands of connectivity. So once we go to 5G, the number of connections multiply by 10, 100 times, and the bandwidth that we're talking about increases by 100 times. So it's not just like increasing by a few times, like between 3G and 4G. From 4G to 5G, the multiply could be 100 times, higher bandwidth, much more connectivity. So that's why 5G is so much different than 4G. I'm going to talk more about the use cases, how we're going to use 5G. It will be much more persuasive in society.
Hi, Dennis. Sorry.
Yes. Hi, Cindy. Hello. I cannot hear you, Cindy. Oh.
Really?
Yes. Can you hear me?
Yes, we can hear you, but
Oh. The slides are not very clear. Okay. Shall I continue?
oh, please.
Okay. Yes. Sorry for the, because I think for Zoom online, it's always have challenges. I will repeat what I say. I will not totally rely on the slides. So for the outlook, so what do we see going to happen in the next 5 years for 5G? What we have seen in the US, in China, and other places, companies or governments have been deploying 5G for about 2 years. In Verizon, we started 5G in 2 years ago. And so for companies, for many companies that are starting 5G, we see that by 2025, in about 5 years, 2.6 billion 5G subscribers will be there. That is about almost 1/3 of the world's population. That is actually fairly amazing. So we'll be seeing, I think we are on track in doing that. About 30% of the population will be covered by 5G in 5 years. And more traffic, because 5G is going to carry much higher bandwidth. So about 45% of the mobile traffic will be on 5G. And in China, there's a projection that 56% of the mobile subscription in China will be 5G. Actually, in the US, I think the projection is about 70%. So actually, in 5 years, in China, US, more than half of the subscribers will be on 5G, which means that they're on 5G or also 4G, right? So if you see here, in the next few years, there'll be a lot of, I would say, investment in 5G. And this 5G is not only going to just impact consumers. Many industries will be impacted by 5G. For example, if you're medical, finance, manufacturing, high tech, all these industries can take advantage of 5G. So what are the 8 currencies of 5G? What are the benefits of 5G? So when we think about 3G to 4G, it mostly speed. For example, like what 4G enables is that when you, for example, watch a video on your smartphone, it's much better than 3G. So the difference between 3G and 4G is mostly speed, the speed of download. That means you can watch video much faster. But for 5G, much more than that. There are 8 currencies of 5G. The first one is speed, peak data rate. For 4G, it could be up to 100 megabit per second, 200 megabit per second. In 5G, we are talking about the peak data rate to be 10 gigabit per second, which is 100 times higher than 4G, 100 times. Imagine what you can do if you can download that much faster or upload that much faster. You can enable many new technologies that can never happen. For example, you can upload video from your home, for example, like to YouTube or to Facebook in no time. So this peak data rate is what people expected, right? When they think about 4G to 5G, they expect the data rate to be much higher. The second, actually very important, is the mobile data volume. It's 10 terabit per second per square kilometer. What this means is that Not only individually, you could have much higher data rate, but in a particular area, you could have many more of these connections. For example, I mentioned before, in the home, now we may have 5 to 6 or 10 devices. In the future, we could have 100 devices. What this actually means, the mobile data volume, is that you could have many, many more of these devices uploading or downloading at very high rate. That means you can support 10 times, 100 times more devices in the same area. The next one is mobility. 500 kilometers per hour. That is about 300 miles per hour. That means that you can support high-speed train, moving at very, very high velocity. Connected devices. 1 million connected devices per square kilometer. This is related to the mobile data volume. That means that we can now support many, many devices. For example, if you look at a factory, not only the robots have connectivity, all the other equipment, and maybe even some of the devices inside the factory will be connected. So in the factory, you could have 100 or 200 robots. If you're manufacturing vehicles, the vehicles themselves may have connectivity. So you could have thousands, tens of thousands of stuff like vehicles in the factory that have to be connected. So we can cover a lot more devices per area. Energy efficiency, 10% of current consumption. I think all of us have to charge your phone every day or a couple of days, right? Every couple of days. It's very annoying. But think about if you have to put a pacemaker in your heart, which can connect you outside and send information to your doctor. You don't want to take out or to replace battery in your pacemaker. Energy efficiency is going to be very, very important. We don't want to change out battery, for example, for your water meter. Service deployment time, 90 minutes. What this is that we can deploy new services or new applications very, very quickly. We can have software-defined application on network that we can deploy services. That means that we can develop applications that can be deployed very, very quickly. Reliability, 5.9. This is especially important if we have to help autonomous and connected vehicles to be safe. It's very important if we have to help nuclear plants to be safer. And the last one is latency. Latency means that the time it takes information to go from one place to the other. It's 5 milliseconds. Think about if we have to control an autonomous vehicle remotely, we want this latency to be very short. Otherwise the vehicle may hit another vehicle or it may hit a pedestrian. So if you look at these 8 currencies, it's not only bandwidth, it's not only higher speed, but it can support 100 more times more devices. It's much less energy consumption. It's much more reliable, and the latency is much shorter. With all these 8 currencies, we can impact society, we can impact industries, we can impact how we conduct, for example, medicine. Remote surgery will be possible in the future. So I'm going to spend a few minutes talking about what are the building blocks, what are the technologies that enable the 8 currencies. I'm not going to spend a lot of time here because I know that for the attendees, there are people with maybe some technical background, some of them may not be. So this is more a general introduction of the building blocks of 5G. The first one is called OFDM, which is actually orthogonal frequency division multiplexing. That means that I would say the method that we transmit information from the cell tower, from network to your cell phone, is more optimized so that it can support much higher bandwidth than what 4G can be. The second one on the right is called a common flexible framework. This is about how we transmit the information. Now it's much more flexible so that we can support lower latency. For 4G, the latency could be 20 milliseconds, 40 milliseconds, but now with this flexible framework, the latency could be down to 5 milliseconds. The second building block is called MIMO, multiple input, multiple output. If you look at your phone, you cannot see it. There are multiple antennas in your phone. That means that you may actually receive two information at the same time to your phone for 4G. In a way, making your receiving of information faster because you can receive twice as much information if you have only one antenna. So 4G has maybe two antennas, 2 by 2, 2 input, 2 output. In 5G, we could have 100 antennas, 200 antennas, and we have something called beamforming. We can focus the energy on a particular smartphone. We can have much, much faster speed with this beamforming, what we call massive MIMO. We could have 100 input, 100 output in the antenna. In your phone itself, you could have 2 by 2, but in the big antenna, we could have 100 by 100. That's a term that you may be hearing or you may have heard. It's called dynamic spectrum sharing. One thing about wireless, the limitation about wireless is spectrum. Spectrum means that, for example, if you listen to radio, you could tune to a particular FM or AM. Basically, those spectrum is actually very, very, I would say, scarce and very expensive. So the limitation is that once we go to 5G, where can we find the spectrum to convey all this information using 5G? And that's a technology called dynamic spectrum sharing. And what this does is that we can share 5G with 4G. That means that, for example, like if you use a particular spectrum for 4G, now we can use that spectrum for 5G. And if no one is using 4G, we will dedicate that to 5G. Or if someone is doing 4G, if someone in that area is using 4G and 5G, we can share that. So that's why it's called dynamic. The spectrum, for example, if we have 100 megahertz for 4G, now that 100 megahertz can be dynamically shared between 4G and 5G. This is actually going to be very, very important because we don't have enough spectrum just to dedicate to 4G or just to dedicate to 5G. We can share that spectrum between 4G and 5G. So I'm going to talk about these building blocks fairly quickly. I think for you, maybe that's kind of confusing. I just want to let you know the terms. Dynamic spectrum sharing, MIMO, OFDM. At least you have some idea about the terms or the technologies underlying 5G. And that's another term called network slicing, which is actually very important. Network slicing means that we can slice the network. It's like you can slice the network or divide the network into different pieces. For example, you could have one piece of the network that support broadband, one piece of the network that support machine-to-machine, one piece of the network that support mission-critical for some autonomous vehicle, and one piece of the network that support future applications, for example, like IoT, Internet of Things. And this is important because each piece of the network can have different characteristics. For example, like for the first one, for the mobile broadband, very high speed. You could be downloading video, but just regular latency. It's not, you don't need to be very low latency. But then for machine to machine, for example, if you are controlling robots, you may not need very high speed, but you need to be very quick. Otherwise, your robot cannot handle the task. So it's low latency. And if you have to control mission critical action, for example, if you have to control autonomous vehicles, you want both very high speed and very low latency, because you may be seeing the video from the vehicle, and at the same time, you have to control the vehicle. That means that you need to be very, very high speed so that you can see the video in real time. At the same time, you need very low latency so that you can control the vehicle. You have to steer the vehicle. And for the future applications, it could be high speed, but extremely low latency. So good thing about network slicing is that you can divide your network. Right now, our network is one size fits all. Our network is of the 4G network cannot be customized for a particular application. For 5G, you can customize the network for your particular application. For example, here, it did not show. For the mission critical, it could be remote surgery. For remote surgery, you definitely want very high speed and very low latency because the doctor, the surgeon on the other side, need to see the patient and need to control the robotic arm. So you need very low latency and extremely very high speed and extremely low latency. So network slicing in 5G can enable different applications. In addition to network slicing, another important technology is called edge computing. Edge computing means that we bring the server or the cloud all the way very close to the, I would say to you. If you look at what we have right now for 4G, many of these applications, for example, if you want to access a website, if you want to watch a video, you go to 4G and you go to cloud. Sometimes you have good response, sometimes you don't. Sometimes you could wait for a second or two before you can see the video. But think if we are doing remote surgery, you cannot wait for a second, you cannot even wait for half a second. So what's going to happen is that there will be an edge compute between you, 5G, and the cloud. That means that you don't go to the internet. There will be edge compute, which is very close to 5G. So you don't have to incur the latency or the delay in the cloud. This edge compute will be very close to the central office of the mobile operator, like China Mobile, and it will have much lower latency or delay. So I'm basically done with all these basic technologies of 5G. And there are some questions I'm always being asked in this kind of conferences and talk. How about health concern? I think we have heard about this health concern, not only with 5G, but with 4G. But with 5G and also with the pandemic, some people are thinking that, oh, would 5G cause any cancer or cause any issues? So there are lots of, I would say, news about this. And we have to understand the basic technology behind 5G. So if you look at 5G, if you look at the chart over here, this is about low frequency and high frequency radio waves. So on the left-hand side, the low frequency is radio, mobile phones, and microwave. So 5G is actually fairly low frequency in terms of the radiation, what we call non-ionizing. That's the difference between non-ionizing radiation and ionizing radiation. When the radio wave go higher frequency, it's going to ionize. Ionize means that it can basically damage your skin. But it has to go to ultraviolet, X-rays, or gamma rays. You have to go much higher frequency in order to be ionizing. For 5G, if you look at the spectrum over here, 5G is actually much lower frequency than even visible light. So when people talk about 5G, okay, they may not realize that the frequency of 5G actually is much lower than visible light and even microwave. So it belongs to the non-ionizing radiation. It means that it will not damage your skin. So okay, let me go back. That's a I would say an international organization called International Commission on Non-Ionizing Radiation Protection. This particular commission has done many studies and also reviewed a lot of peer-reviewed articles to understand whether all this radiation have impact on human beings. And in the latest study, all the latest study do not provide evidence of carcinogenic effect, that means cancer effect, of radio frequency, that means that the 5G frequency at the exposure level, that will have cancer effect. I have seen some study which basically say that, the radio waves, for example, 5G or 4G could have impact on a mouse, for example. But if you look at the studies carefully, the radiation level of those studies usually is 100 times or 1,000 times more than the levels that we have in our 4G and 5G system. So for example, like if you expose a rat 100 or 1,000 times more the radiation, definitely you have an impact. That means that if you're under the sun 24/7, then you have an impact. But our 4G and 5G base stations are all under strict regulations. They can be the power level they are emitting are actually fairly low level. So when we look at some of the report, we have to be very careful about how they conduct experiments. So at least for now, based on all the studies that IRP has done, there's no measured cancer effect on human beings. So I think, science is science, right? We have to look at evidence instead of like just hearing rumors. I think that's very important for us to understand. The other bit, security, is that if 5G is going to impact our society, not only with our smartphones, but connecting to our homes, connecting all the factories, connecting all the autonomous vehicles, I think one thing that has been asked is how secure 5G is. Definitely we know security is actually very important. And also many times hackers are trying to hack into all these systems, right? So in 5G, I'm not going to go in depth about here. There are 5 areas in 5G that are very important for security. For example, like identity management. How do you make sure that you are the person that I'm talking to? Privacy means that no one is eavesdropping my conversation. Security assurance means that nobody's going to break into my system. Resilience means that my system can stand up, it's not going to fail. Communication security is that there'll be encryption. It means that when I communicate with you, I'm pretty sure that it's going to be secure. All these, for 5G, there are significant effort in trying to make sure that all 5 areas are enhanced. We know that security measures, security advancement is always difficult. And 5G is putting a lot of emphasis on security measures. So now we are done with the building blocks of 5G, health concerns and security issues. I'm going to talk about the use cases. The use cases of 5G will be much more than 4G, much more than 4G. The first phase of 5G, what Verizon did is that home broadband. We are basically going to support 5G at home. We started it in 2018, 2 years ago. The phase 2 of 5G is mobile. That means that we support smartphones and for example, connecting the office to 5G. Phase 3 of smartphone, which is what we're doing now and beyond, is what is interesting. Cloud, AR, VR, autonomous vehicles, remote diagnostics, medical diagnostics, industrial automation, connecting robots, video surveillance. We can connect to all the videos and be able to upload the video. Smart cities. I think Shanghai, Beijing, many of the cities in China are moving towards to be a smart city. Logistics and supply chain. We can connect to vehicles, collect information and sending route information so that, for example, Alibaba vehicles can route to your house much faster. Intelligent lighting. How can we control all the millions of lights, street lights in the world? How can we connect them? How can we make them more efficient? For phase 3 of 5G, it's not only connecting your smartphones, connecting your offices, but connecting to the world, everything in the world, in society. I'm going to go into some of these use cases in more detail. High bandwidth. If you are in Shanghai or Beijing, right, your office will be connecting to some kind of fiber. You are getting, for example, your internet, right? In the future, you don't have to connect to fiber. Because connecting to fiber is actually very expensive because you need to dig the road for fiber, you have to maintain them. But in the future, you can connect directly to 5G site. You could have an antenna in your building. The antenna is going to connect to all the offices in that building, and the antenna is going to connect to 5G. But 5G is going to have a high bandwidth. It will be able to support many of your offices, and your office could be further away without fiber access. So it will be much faster. It will be as fast as you have now with your fiber. The second one is we can connect, it's high speed. A lot of increased traffic, we can connect to intelligent video, we can do remote telemedicine. We can basically upstream our video. So basically we can be able to have extreme mobility. We don't have to be connected. For example, what we are looking at, for example, like remote medicine, is that we could have some big hospital in big cities, and we could have remote vehicles or medical vehicles in small cities, and the surgeon can remotely perform surgery. Right now, patients have to drive or have to drive from small cities to big cities to do surgery. In the future, surgeons could perform surgery remotely using 5G. The next is low latency. Low latency is the one that I've been focusing on. Is that we can control or help autonomous vehicles to be safer. So I think in China, I've seen that there are lots of companies that are trying out autonomous vehicles like Baidu. Those vehicles, they can see what they can see with their sensors. But with 5G, 5G can sense a lot further away. For example, if you turn right, you may not be able to see the pedestrian, but there could be video cameras in the intersection that can send you information so that the autonomous vehicle can avoid hitting the pedestrians. So you can avoid collision avoidance. And also high precision manufacturing. You could remotely control your robots. So with low latency, you can automate, for example, your vehicle fleet, you can automate your factory.
Verizon's 5G network is now live at the University of Michigan's testbed for driverless cars. It's called M-City, and today we're unveiling some of the 5G tests we're doing there that will help make our roads safer and potentially save lives. Anthony's there with more.
I'm here at M-City where we're installing 5G connected cameras at every intersection to identify patterns in car and foot traffic and help avoid accidents. Verizon 5G ultra-wideband is crucial here because when you think about the massive amount of data being transmitted by sensors in cars, streetlights, and traffic lights, as well as the super low latency needed for autonomous cars to stop on a dime, only 5G can transmit all the data faster than the blink of an eye.
Verizon is one of M-City's 11 leadership circle companies, which includes automakers, insurance companies, tech companies, all here to help shape the future of transportation through research and testing. We're here in M-City's test facility. This is a 32-acre miniature city. It really represents the real world. So this is a great place to test early technologies, understand how vehicle safety applications can be built. And I think technologies like 5G, this is a natural place for them to start before they're deployed in the real world.
When you consider that about 4.5 million people are seriously injured in car accidents every year, and 94% of accidents are caused by human error, using 5G to support driverless cars could potentially save countless lives.
Actually, this is my favorite video because me and my team are responsible for 5G and autonomous vehicles in Verizon. And I've been to M-City multiple times with my team and other teams to conduct experiments and pilots with 5G, edge compute, and also autonomous vehicles. And it's very, very exciting. that we all know that maybe in 5, 10, 15 years, autonomous vehicles will be a very important part of our lives. And we hope that 5G is going to help that. Because as we look at what many of these companies are doing, Baidu, WeShare, Waymo, Tesla, all these companies are doing, they're relying on the sensors in the vehicles. For example, like the LiDAR, the radar, the cameras. But those are very expensive. The sensors can easily be $20,000, $30,000 US. And imagine when you're buying a vehicle, you don't want to spend so much money on those sensors. And with 5G, we will be able to send information to the vehicle to understand the surroundings, whether it's going to hit someone, it's going to hit a vehicle. Hopefully, it's going to be safer and also reduce the cost of the vehicle. So I'm very excited. Me and my team are very excited about what 5G can do in the autonomous and connected vehicle space. And I think there will be a lot of advancement. And the next one is about massive scale. As I mentioned before, that 5G can support maybe 1 million devices in 1 square kilometer. That means that in your house, in your factory, in your office, everything can be connected. And the advantage of connectivity is that you can reduce, for example, like you can save money in terms of, for example, your energy costs. If you can have more sensors in your building, that can help you understand how you can cool or warm your building. You can actually save a lot of money. For example, you can have connectivity to your shoes, for example. That can measure, for example, whether your shoes is doing well. It's helping you helping your feet, for example. Like if you walk a lot, maybe you can have sensors in your shoes that basically can say that, oh, maybe now I have to replace my shoes. So right now we don't know yet how we are going to, I would say, implement this technology. But if you think about if all this connectivity is going to be much cheaper, and also you are able to, I would say, connect to almost everything in your house, in your factory, how would you be able to make your infrastructure more, I would say, efficient? For example, like your lighting in the street, it could be much more efficient. So a lot of these 5G applications we're still exploring. So we are actually having a lot of collaboration with companies and startups to understand how we can innovate using 5G. Manufacturing is very, very important because if you look at some of the companies, they have hundreds and thousands of robots. And you think that, well, what's the use of 5G for robots in factory? Right now, the robots in factories are using fiber. And you may say, why don't they use Wi-Fi, right? Because Wi-Fi doesn't provide the quality of service. Think about if you are using robots to manufacture vehicles, you want the robots to be 100% up all the time. You don't want to be a delay. Wi-Fi doesn't really provide the, I would say, the quality of service for factory automation, but for 5G you could. That means that you could be able to connect all the robots to wirelessly using 5G. That means you can reconfigure your factory much faster using 5G than having a lot of cables in your factory. We're working actually with a company to automate their factory. Let's see the video.
Verizon's 5G network is now live at Corning's Hickory, North Carolina plant. Today we announced we're teaming with Corning to create the 5G factory of the future. Here we'll test how everything from product inspection to autonomous guided vehicles can work better on 5G.
Corning and Verizon have always been leaders in telecommunication innovation, and 5G is the future of telecommunications. That future is enabled by optical fiber and cable that Corning produces.
5G is crucial in a manufacturing plant to allow for the low latency that's needed for industrial IoT. We have installed a 5G testbed system to start collaborating on different industrial use cases with Corning. Some of the 5G use cases include computer vision, industrial IoT, and autonomous guided vehicle enhancement. 5G's high bandwidth will allow for the massive influx of data from the factory floor, making the rest of the factory process efficient.
We really have an opportunity to test 5G capabilities in a real-world environment and revolutionize manufacturing, not just for optical fiber and cable, but for the entire manufacturing sector.
We say 5G can pave the way for the fourth industrial revolution, and when you're on the factory floor, you can see how big of a deal that is. Get ready for the 5G factory of the future.
So actually, we are working with Corning. Corning is a major supplier of fiber optics to Verizon and to many companies in the world. And so we install 5G at Corning so that, for example, like they can use cameras to inspect the fiber and be able to see if there are any defects in the fiber optics. And the cameras are connected to the 5G so that it can basically send video to 5G. Actually, the reason why we need 5G is because if we use 4G, 4G doesn't have enough bandwidth to support all the videos coming from the cameras. And we're also using 5G to control the remote kind of like vehicles in the factory itself. The vehicles themselves, they basically transfer material in the factory floor. So we're working with many of these innovative companies, manufacturing companies, to understand how we could use 5G to automate their factory. So I'm at the end of the talk. I think what you have seen or what I've shared is that 5G is not just about having a high speed in a smartphone. 5G is going to have impact on factories, on how we conduct medicine. We can do remote surgery, how we're going to control and help vehicles, autonomous vehicles and connected vehicles to be safer, how we are going to connect to homes. Our homes will have much more devices, many more devices in our homes than just 5 to 10 devices that we have right now. So if you look at 5G, the possibility is infinite. Right now, we are at the very edge. We are just deploying the basic technology, 5G, but we are working with many startups, many companies to understand how we can innovate together using 5G. I think collaboration is the term that I often use in 5G because no one company can, I would say, win. We have to collaborate among different industries. So Verizon or maybe China Mobile, China Telecom have to collaborate with other industries in order to utilize or fully utilize 5G in their respective industries. So I hope that this talk is not just, I would say, information only. I hope that no matter what industry you're in, you can think about how 5G can help you, or you can use 5G to your advantage, right? To innovate in your particular industry. So I hope this talk is interesting and helpful to you. So I give the time back to Cindy to see if there are questions that we could answer. Hi, Cindy.
Thank you, Dennis. This is a great walkthrough of what 5G is. As a non-technical person, we keep hearing about 5G in China, never really understood how that would be able to impact our life in the future. And we have some great questions in the chat room. Let's go over them. The first question comes from Gregory. Question is, a real global risk of 5G dissemination led by China and its tip of the spear, Huawei, is the prevalence of the surveillance state. How can that be prevented while still realizing the full potential of the technology?
Yes, I think I've heard about this a lot, about the danger of surveillance, the danger of 5G. To be honest, I'm probably not the right person to answer this because this is more political in nature. So I don't claim myself to be a politician. And I would say even in the US, there are lots of concerns. For example, like I can tell you my experience. I used to be in the smart city division in Verizon. And when we work with like cities, the first question they ask is that we cannot share all the videos from 5G and from our smart cameras. I cannot talk about different cities or different countries in the world, but at least I know that in the US, when I work with different cities, they have their own regulations, very strict regulation that I cannot share the information that we connect from a 5G network. Definitely, that is more than just US, right? I mean, this is a really a global issue that that politicians and countries have to address. And I'm not probably the right person to address that here.
And I think that's very fair. The next question is about what's the difference between mobility versus rate? Both mean fast. And we had a...
Oh, I see.
Shoaib helped answer the question, actually, mentioning rate is the throughput or speed of connection, while mobility is the speed at which device can be moving during the handover from one cell to the other. Sounds like we have a few experts on the call. So if you have anything else to add, Dennis.
Yes, rate, I think sometimes people call like download speed or whatever. It's actually how fast you can receive the information in your cell phone. For example, with 4G, you may see a delay because of watching a video, and with 5G you may not see it. So that is more the rate or the speed. Mobility is that if you are like sitting in a high-speed train running at 300 or 400 kilometers per hour, you're able to receive 5G with no problem. Yeah.
Got it. Thank you. The next question is, can Starlink project from Musk replace some functions of 5G?
Yeah, I think this is a very specific question, and because Elon Musk has proposed using Starlink, which is actually a load rotating satellite, and be able to, those satellites are much lower than regular satellites. And actually, Elon Musk is seeking to get some funding to do that. Not quite sure, because I think if you look at this, this is still, I would say, conceptual stage. Elon Musk may have sent 1 or 2 satellites, but in large scale, it's hard to say. So I would say that for specific applications, maybe, but for high density, that's the issue. For high density, the Starlink project, I don't think it's intended for big cities like Shanghai or New York, because it cannot, I would say, support the high density. It's more intended for rural areas where you don't have high density. So I think the application of Starlink is quite different than 5G. I would say that those are complementary, because 5G cannot cover everywhere. It cannot. It's too expensive. So 5G is mainly going to be focusing on large cities and high dense areas for now. So I think Starlink is complementing to 5G.
Great, thank you. Do you see Wi-Fi 6 as competition for indoor industry 4.0 application?
I think Wi-Fi definitely is a very interesting applications, and I would say it will be. I would say it's a competition. Competition is good. Competition is good. 5G alone cannot solve the world hunger. We cannot solve all the issues in the world. So Wi-Fi 6 and is going to help. To be honest, I think all these I would say technologies are using similar technologies, or maybe a little bit different. But the thing is, underlying technologies, many of those are the same. So I would say Wi-Fi 6 can solve some of the problems that 5G cannot solve.
Great. Can you elaborate a little bit on smart factory, on the basic structure and applications?
Okay, so let me tell you about Corning, for example, or maybe some of the factories, some of the companies that we're talking to. For example, now, like in some of the companies, they may have 100 or 200 robots. And what they have right now, as I mentioned previously, that they connect those robots to with cable. First, they want to have to make sure that it's 100% secure, and also they have the high speed. But if they have to reconfigure the factory, for example, if they have to manufacture a different vehicle, they may have to reconfigure their factory. It takes weeks and months to reconfigure the factory, and it's a lot of downtime. It's a lot of money lost. So imagine that all the robots are connected wirelessly to 5G, so you don't have all these cables. You can reconfigure your factory much faster. So that is one application that we see. The other one is definitely smart camera. We can use a smart camera to basically do inspection of all your products. For example, in the example of Corning, the fiber optics. And actually, we are working with many other companies on basically using smart camera or different sensors to inspect their products. If we can connect all these to 5G, it's much easier to configure and much faster to basically to be able to configure your factory.
Great. What's COVID-19's impact on the overall 5G development in US and global?
Well, actually, I mean, I can speak only for, well, I can speak for Verizon. Actually, we publicly mentioned that we are spending about $16–17 billion this year for 5G deployment. We are spending more. COVID-19 is not stopping us. Although, I mean, there's impact on, for example, like our workers going out to install, but it's not impacting us significantly. We are moving very quickly because if you look at COVID-19, almost from home. And there's actually more need for connectivity than less. So COVID-19 actually is pointing to the direction is that if you look at many companies, right? Many companies, they may have the workforce working in the office all the time, but not all of them working from home. And even if COVID-19 is gone, many of them will stay working at home. So we see that the need for connectivity, for need for high speed, for need for low latency is going to get more and more important in the future. So it's not stopping us.
Cool. How will 5G change the education industry? What change can it bring to the university, especially like University of Chicago?
Yeah, I think remote learning, I think like this, right? I think it's going to be more important. As all of us see now, even the university, I think they will have limited enrollment in-person teaching in the future. So I think remote learning is going to be important. So I think 5G can bring that even more extent. I think now, if you look at our remote learning using Zoom is actually pretty lame, pretty inefficient. If we can go to VR, AR, virtual reality, and augmented reality, our learning will be much more effective. So right now, if you are using 4G, for example, Cindy, I think you are using 4G, right, on your smartphone. In the future,
True.
if we have 5G, you will have glasses that can do AR, VR, 3D. 3D learning instead of 2D learning. Right now, we are doing 2D learning, right? We cannot visualize. For example, like in the future, you could visualize. You could have a AR, VR goggles, and you will be able to see 3D in the future. Our sharing will not be only 2D, will be 3D in the future. So our learning can be, for example, like think about chemistry, physics. A lot of times, the way we learn is actually very ineffective. If we can see the atoms in for example, like in chemistry lesson, if we can actually touch it using 3D, how that's much more effective than 2D. So I think the education industry, I think, is actually fairly far behind in other industry because, for example, like in manufacturing, there's a lot of money involved, so companies are moving very quickly. Education industry, I would say, is actually fairly behind in technology.
Has current 5G technology solved the penetration issue, i.e. going through the wall without too much loss of signal strength?
Yeah, 5G technology cannot solve the spectrum issue. That means that, for example, like if you have low frequency, you can penetrate walls. If you go to high frequency, like millimeter wave, like 38 gigahertz, it cannot penetrate walls. For example, like the difference between sound and light. Sound is low frequency, light is high frequency. Sound can penetrate walls, but light cannot. So that is the analogy. What we are doing here is that, if you remember, I mentioned before something called like dynamic spectrum sharing. That means that we don't need to deploy 5G only on high frequency. We can share 4G spectrum with 5G spectrum. In that case, 5G spectrum can also ride on low frequency, for example, like 600 megahertz or 900 megahertz. That's why dynamic spectrum sharing is very important for 5G.
How operators will deal with 5G network configuration or optimization issues, considering that they are already struggling with 4G networks that have much less parameters?
Yeah, that's what we have to deal with. The thing is, I think one thing I want to point out is that it's a process. It took operators about 10 years to deploy 4G. in reality, because I was actually helping Verizon to deploy 4G 10 years ago or 15 years back. So it's going to take operators about 10 years to deploy, really fully deploy 5G. We're at the very beginning of 5G. So, so operators have to learn. I mean, Verizon have to learn. So we are learning in this process. So 5G is not going to happen. I was in the happen. 5G is happening, but to really cover a good channel area to provide significant value, it's going to take years to do it. So we are at the very beginning of the journey. So we are all learning. I mean, and a lot of these companies, Nokia, Huawei, and Ericsson, and us are doing a lot of AI. So if you look at the industry right now, in the past, it's a lot of manual work. We are basically going to install, for example, like the base station. We're going to do this manually. But now we are doing a lot of AI to understand how we can automate the process using AI. So what we are seeing in 4G, hopefully we can, I would say, resolve some of the issues using AI.
Let me share an analogy I hear from an investor in China. He mentioned that before there is highway, when people told him, oh, in the future, we're going to build a highway without any traffic lights. And he remembered he felt so excited thinking, oh, how wonderful that is. And now look at what our lives are with highway. We are still facing traffic jam.
Yes. Actually, when you talk about this, actually, I'm involved in the project. So, for example, and I think in China and in many places in the world, in the US, there are a lot of traffic jams and congestion in big cities. What we're doing is that actually we're thinking about actually going to implement something like using 5G to help to have automated vehicles in the highway to automate traffic. For example, like we could have, for example, like in a 6-lane highway, we could have 6 autonomous vehicles, and those vehicles actually could serve as a traffic light on the highway. That means that they can guide the vehicles through the highway. And in some of the studies, if you do that, you can increase the capacity of highway by 30%. So there are a lot of interesting and very innovative ideas how we can solve problems that we cannot solve right now using 4G.
Great. Do you mind explaining a little bit more on dynamic spectrum sharing? I think some people might not really understand it because we don't have technical background. It sounds like such a technical term.
Sure. Yeah, I'm sorry that I go over that fairly quickly. So think about this, like for example in China or in the US, the government may have allocated some spectrum, radio frequency for 4G, for example, like 900 megahertz. It's like when you listen to a radio, you tune to a particular base station. For example, the government has allocated 900 megahertz for 4G. So if they have to deploy 5G, they have to find maybe some other spectrum, like maybe 1.5 gigahertz. But those are very limited because people have been using it. Satellite companies, military, all of them have been using them, right? So how do we have, I would say, spectrum of frequency for 5G? So one idea is to share. So for example, for 4G, it's using 900 megahertz. Now 5G comes along and say, oh, well, can we share? For example, like in a vehicle, think about like a vehicle. 4G is that vehicle, right? So 5G comes along and says, oh, can you share a seat with me? If you have no passenger here, I can share a seat. So that's what it's doing. I'm not going to buy another vehicle. I'm just going to share what you have in 4G. So that's what's dynamic spectrum sharing. And the reason why it's dynamic is that, for example, that you have a vehicle with 2 seats. If 4G, if you have 2 people with 4 seats, for example, in 4G, if you are using 2 seats, you can have spare 2 seats for 5G. If you're using 1 seat, you can spare 3 seats for 5G. If you're using all the seats, you have no seat for 5G. That means that we dynamically share depending on the capacity that 4G and 5G have. So that's why it's dynamic spectrum sharing. This is actually very important to be able to utilize all the spectrum for 4G and 5G. Hello, Cindy, I cannot hear you. Cindy, I still cannot hear you.
Oh.
Oh yeah, I can hear you now.
Okay. Okay, let me go over the question again. Trends and patience.
I cannot hear you, Cindy. Maybe I can look at the maybe I can look at the chat. I think one of them. Okay, yeah. I think one of them is about what are the business and political implications we should be aware if we want to need to work with 5G, not limited to China. 5G. I mean, I think the person who wrote this actually knows about 3GPP and all this stuff. So as all of us are aware, 5G is not a localized standard. It's not a standard particular to a country. It's based on called 3GPP. It's a global standard that all the companies, many of these companies come together to work on it. So the standards are the same. And we, for example, Verizon work with almost all the telecom companies in the world to do global roaming. So this is not new. Since 2G, 3G, and 4G, this is not new. So for 5G, it's the same. We are going to follow the same protocol that we're going to work with different operators for global roaming. So the business and political implications, I think what's going to happen is that for can someone put on mute? If not, you're not talking. Or Lenora, can you make sure that yeah, it's quiet. And I think the implication is that 5G and the difference between 4G and 5G is that it's going to impact many industries. 4G it does, but it's not to the extent. So in terms of business, political, I cannot tell about political because I'm not in that aspect. For business, if you are in business, for example, if you are working with a large, for example, like a large car company, for example, okay, which I'm dealing with them all the time. I have regular meetings with car companies, and they have global operations. And what they want to do is that they want to standardize on 5G. That is I would say, the implications. For example, like they want to work with the same company on 5G, for example, the same standard, so that when they manufacture the vehicles, it can work in China, it can work in US, or whatever, at least for connectivity, for 5G connectivity. They don't want to customize that for China, customize for Europe, customize for India, customize for US. They want to make sure that in the future, this is going to be a global product, global solution. So I think what's going to happen in the future, many of these big companies which are global, they want to make sure that the 5G that they implement basically can be applied globally in every country. Okay, this is actually interesting. How will 5G affect future human capital? Will it create redundancy, and which industries will be highly affected? The thing is actually, I think this is not only 5G, right? I think as we talk about technologies, 5G, artificial intelligence, AI, all these have impact on human capital. I think the way I look at it is that 5G by itself is not going to, I would say, reduce or create redundancy. I think the more important thing is that we have to take advantage of 5G. It's the same as we have to take advantage of AI, right? For example, if you look at autonomous vehicles, people think about AI or 5G can help autonomous vehicles to be autonomous very soon, but it's taking forever. It's really taking forever. As human beings, I think we can take advantage of 5G. I think the way I look at it is that, and the reason I'm giving this kind of talks is that all of us here can take advantage of 5G in our respective industries or our disciplines. For example, like one question about education, right? One education about manufacturing. You will not be redundant if you can bring 5G, if you can bring value to your company. For example, in manufacturing, if you can say that, okay, in the past, we need 2 months to reconfigure our factory to do a different, to manufacture a different vehicle. Now it's going to take 2 weeks because we are going to have all the robots connected to 5G. You are not going to be redundant because you are going to be a value to the company because you see the future. So the way I look at it is that when we look at all this industrial revolution, it's going to, I would say, it's going to, create new industries, new capabilities, but it will make some of our skill set obsolete. So as human beings, I think we have to learn how to take advantage of those. Some of the political questions I really cannot answer. Let me see. Do you see the future unicorns will be companies that have innovation leveraging on 5G? Do you see this happen in the next 5 years or longer term down the road? Okay, this one I can answer. But I'm working actually with many startups and many industries on 5G. To be honest, I mean, right now it's very early, even in China, right? In China and US, because if you look at the deployment of 5G, although it's moving up, but if you look at the time frame, it will be the next few years, right? 5 years before 5G will be actually making a very meaningful impact to a lot of the industries. So I see that, and I'm working with many unicorns actually that want to take advantage of 5G. And I would say that it's going to take a little bit time because it's not like the internet right now. For example, for the internet, if you develop a good applications, you can reach billions of people. For 5G, it's still fairly limited right now. So I would see that I would say unicorns this term. It's difficult because sometimes when people see unicorn, they may think that, oh, you can make a lot of money in half a year, in 6 months. I think for 5G, it's going to take a bit longer because we are still building out the 5G, I would say, network. So I would not use the term unicorn, maybe startup, because I don't think a unicorn can make money, a lot of money in half a year on 5G. Okay, any good introductory book and material of 5G for business beginner? I'm not aware, I'm sorry. Maybe I can research it. If I find it, I will send it to Cindy. Because I think Cindy has your information. So if I find any good material about 5G, I'll send it to her. Yeah, I may have some already, but I will take a look which one is good. Yeah, I have some like good videos and good papers on 5G. I think that those are good for beginners. Okay, Cindy, do you think I'm looking over some of these are political questions and I'm not going to answer. Let me see if there's any good ones. So Cindy, do you have any question for me or? Cindy, I still cannot hear you. Okay, and thanks a lot. And I'm on LinkedIn. So if you guys are interested to connect, you can connect me to LinkedIn. I'm always interested in I'm connecting with both alumni and others. It's a small world. So let me say, this is a good one. 5G needs a lot of base stations. Is it possible for us to construct? I'm not sure who is us. Definitely. Definitely, I mean, 5G because 5G actually, I would say, has to support high bandwidth, so it needs a lot of base station. So companies, for example, I read a report that China has deployed like 200,000 small cells or 5G small cells, and other countries will do the same. So yeah, so there's a lot of deployment of 5G base stations, but I'm not sure whether it's us to construct. I'm not sure the answer. This one's interesting. Do you think 5G and AI will take away the cost advantage which low-cost countries have due to low human resource cost? I think the way we look at it, AI actually is very limited in nature right now. So if you look at what AI can do, so I'm a little bit diverting from 5G, but AI right now is a lot more about machine learning, about using machine learning on visual, on, for example, like on camera vision, on so AI is by itself really right now cannot do a lot of this low-cost job. For example, manufacturing genes, manufacturing, for example, like of different parts, car parts, for example, vehicle parts. Those have to be done at low-cost countries. So right now, AI can do a lot, But right now, they are doing a lot of high-level visualization, for example, autonomous vehicles. Definitely, I think AI in the future can do more, but I see that AI has limitation, has a lot of limitation. It's hitting a plateau right now. So I in a way, I think we have to be very careful how much AI can do. Okay, Cindy, I'm not sure whether you're back or I can hear you. So thank you very much. I think I really enjoyed connecting with all of you over Zoom. And I hope that you and your family are safe. And hopefully in the future, I can see you in person, either in Hong Kong, China, or anywhere in the world. And best to all of you. And I hope you have a good day. Thank you. Cindy and Lenora, I'm going to log off. And thank you for hosting this 5G talk. Have a nice day.
Have a nice day. Bye.
Thank you. Thank you.
Bye.
This is really weird.